Welcome back to Mechanical PE Exam Prep. This is Dan, working on 6-minute solutions problem 9. 800 pounds of water is heated to a state where the pressure is 20 psi gauge and only 100 pounds remains in a liquid state. The entropy of the final mixture is most nearly what? And they give us a hint. Property of two-phase mixtures can be determined by using the quality of the mixture to find actual properties between the state points at saturated conditions. So we know the quality of this mixture is somewhere between 0 and 100 because 100 pounds remains in a liquid state. So out of 800 pounds, the other 700 must still be vapor. So mass equals 800 pounds. And of that 800 pounds, 100 pounds are liquid and 700 pounds are vapor. We also know the pressure is 20 psi gauge, which is 34.7 psi absolute. And they want to know the final entropy of the mixture. So let's take their hint and find the quality. We can reference equation 23.30, which you may not need to look up if you have a good understanding of what quality is. But to make it explicit, it's the mass of vapor divided by the total mass, or the mass of vapor plus liquid. So for this situation in particular, we know the mass of vapor is 700 pounds because 100 remains as liquid, so the other 700 is vapor. And the total vapor plus liquid is 800, so the quality is much closer to 1 than it is to 0. It's 0.875. And now once we know the quality, we can find the entropy by looking up in the steam tables what the properties are at the pressure that we have. So for that, let's pull out the steam tables. That's app 23b, which I'm sure you're very familiar with. Properties of saturated steam. And we'll take the pressure rounded off as 35 psia so that we don't have to interpolate, which will slow us down quite a bit. And from the table, let's jot down the entropy of pure liquid at that pressure, which would be 0.3809, and the entropy of vaporization, which is 1.3064. And the formula for finding the entropy of a mixture, which is a good one to know as well, but if you need to look it up, it's 23.54 in the MERM, and the entropy equals entropy of a pure liquid plus the quality times the entropy of vaporization. Always remember SF plus SFG equals the entropy of pure vapor or gas. So this is true for entropy. It's also true for enthalpy, specific volume, and internal energy. Okay, so for our situation, let's plug in the numbers. 0.3809 plus 0.875 times 1.3064, and that comes out to 1.524, which is answer B. That should be pretty straightforward. This is a problem you should be able to pick up some time on.